All right, good morning, everybody. So today we're doing the Algebra 2 semester exam review, the Unit 3 portion, right? So we've already done the Units 1 and Unit 2. So in this video, we're going to be covering the Unit 3, which is going to be incorporating a lot of systems of equations. Okay, so let's go ahead and get started. So this question, it's asking us to develop the system of linear equations for the given problem. You do not need to solve it. So we just need to come up with the actual equation itself. And so a lot of this is really just understanding what's happening here. So it says the theater sells 3 types of tickets: general admission, senior citizen, and child. So let's go ahead and start tagging that here. So we are going to say that X equals general admission, okay? And then we can say that Y equals senior citizen. And then we can take that Z equals child. Cool. Okay. And it says Mark bought 9 general admission, so he did 9 general, 2 senior citizen, and 3 child. So what I would do here is I would already start tagging these. I would say this is 9x, 2y, and 3z. And this is all going to equal $140. So let's go ahead and write out that equation. We'll say 9x plus 2y plus 3z equals $170. Okay. And then it says Sarah bought 5 general admission, 4 senior citizen, and 7 child tickets and paid $173. So we can tag that as well. We're going to say that it was 5x, 4y, 7z, and that all equals 173. So let's write that out as 5x plus 4y plus 7z, and that equals $173. And the last one here, Kyle bought 4 general, 1 senior citizen, and 6 child tickets and paid $116.50. Okay, so then let's go ahead and tag these as 4x, 1y, and 6z. So I'll write that down here as 4x plus 1y plus 6z equals $116.50. And so this creates a 3-variable system, which our 3 variables would be x, y, and z. We don't have to solve this. We're not being asked to solve this. They just want us to come up with the actual equation itself. So you are going to be practicing that on the next problem on your own. And just follow the steps, right? If you notice here, I annotated, highlighted, wrote in there, stated my variables, and that's all very helpful. And so you want to take the time to do that as well. That way you minimize the chances of making an error. So go ahead and try this on your own on this next problem. And so you're going to try doing the same thing, and just hint, your 3 variables would be your trumpets, clarinets, and violins. So go ahead and get started. Let me know if you have any questions, and we'll see you in a bit. But I'm going to go ahead and move on to the next problem. So this one here, we're talking about linear and quadratic systems. And again, this is a system of equations. Unit 3 was systems. And so what you'll notice here is you can have 3 different types of scenarios when we're talking about quadratics with linear systems. You can have 2 solutions, and we know we have 2 solutions because we have 2 intersections. 2 solutions, 2 intersections. Next, if we have just 1 intersection, well, it's just 1 solution. And if they don't cross at all, well, then there's no solution. Okay, so the question says, which graph can be used to find the solution of the following system of equations. And so there's two ways of doing this. We can do it by hand, where we set the two equations equal to each other and solve for x. But we just don't have that luxury. You're going to be having a time test. It's going to be very quick. And so we want to make sure that you're capable of doing this as quickly as possible. So I'm going to show you both methods, but I'm going to show you what I did here in Desmos. When I graph this, you can see here that the line crosses 2 times. So we would actually have 2 solutions, correct? It looks much more like 1 here, definitely not 2. This is no good. This is no good. You'll see the quadratic is more in quadrant 2, so it's got to be this one here. If you were going to solve this by hand, you definitely want to make sure that both equations are set equal to y. So we have that first one at y equals x squared plus 2x plus 3. And the second equation is at 2y minus 2x equals 10. Well, if we were going to do this by hand, we would add 2x to both sides. Simplifies out, we'd have 2y equals 2x plus 10. Divide everything by 2, and you're left with y equals x plus 5. And so if you want to solve for x, you would set the two y parts equal to each other. This part and this part, resulting in x squared plus 2x plus 3 equals x minus plus 5. And we want to set all this equal to 0. So to do that, we would subtract x from both sides. And you could actually subtract 5 from both sides as well. We'll do both at the same time for the sake of time. So we'll say x squared. 2x minus 1x is 1x. 3 minus 5 is a negative 2, and that equals, well, that's simplified out. That's simplified out, 0. You can then split this up into 2 binomials, x and x. We're looking for 2 numbers multiplied that give us negative 2, but added or subtracted give us 1. Well, we know that would be negative 1 and a positive 2. When we set our two factors equal to 0, we would say x minus 1 equals 0. So x equals 1. And the other one would be x plus 2 equals 0. Which would result in x being negative 2. And these would be your two solutions at negative 2 and 1, which it looks pretty close on this graph. And that's definitely happening here at negative 2 and 1 on the x values. Let's go ahead and move on. So I want you to identify the number of solutions happening on this question. Okay? So there's 2 ways of doing this. You can either set the two equations equal to each other and solve for the number of x values that you would get. You could graph it in Desmos as well, but I'm going to leave this up to you and how you want to solve this question. Let's move on. Okay, on this one here, we're given, and you're going to be given a system of equations as such here. And it says solve for x, y, and z. Given the following system of equations, you may use a calculator for this question. So I use Desmos here. And I put the first equation, second equation, and that third equation here. Now, when you graph these, they're not all going to intersect where you want them to. You're going to get this slide bar. And you're going to want to play with this slide bar. Sometimes you need to add it in there, and it gives you the option to add it. It's nothing that you have to put in. It gives you the option to add it in there. If you have questions, please reach out to me, but I will be talking to each and every single one of you while you're in your group work to see if you need help adding that bar. And you'll slide that bar back and forth, and what you're looking for is you're looking for when all the lines cross or intersect, which they did here. And so once you have that intersection point, you see them all cross, you're definitely going to want to make sure that you identify all these values. Well, we do know that our coordinate plane is always happening on an xy. So this would be our x and our y. So if we're solving for these, we're going to say that x equals, well, we get that point at negative 1, comma. Our next point would be y equals, let me go ahead and fix that there, nope. We have it at y equals 1, And when we did our slide bar, you're like, where's z? Well, z is here inside your slide bar, and it says z equals 5. If you were going to put this in a point form, you would say this would be -1, 1, 5. Right? Respectfully, this is your x, your y, and your z. So what I have found seem to be the two biggest mistakes, and you need to be very careful, is one, be sure that you plug in the equations exactly as they are. If you drop a negative somewhere, you're just going to create a lot of problems and headaches for yourself. So be very careful that you're putting these equations in exactly the way they need to be. Okay. The second issue that I'm seeing is students will have difficulty with this slide bar. So please be sure that with the slide bar, you're very careful and you're looking for where all three lines intersect at one point. That's what we're looking for. The solution is the one point where all the values can intersect. Okay, you're going to practice this on your own in just a bit. So on this question, you're going to do the exact same thing with Desmos. You're going to put in all three of these equations in Desmos. Use the slide bar to manipulate where the lines will intersect and identify your x, y, and z. And you'll do that here on the last question. So please make sure that you finish off this semester exam review, Unit 3. You will have 2 more units that will go over Unit 4, which involves quadratics, and Unit 5, which is our radical functions. So be ready for that. Don't loaf on this, guys. Make sure that you finish this up as soon as possible. If you didn't finish in the Unit 1 or 2 reviews, you're going to want to go back and finish those as well. If you have any questions, please message me on Teams, and we'll see you all later today. Bye, guys.